Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on the journey in space will return to Earth as years younger than his brother who stayed on Earth. I'll describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanus, which is about 10 light years away from the solar system. And the speed of the spacecraft is 80% of the speed of light, that is 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times L naught divided by V. So it is the distance between Earth and the star Epsilon times 2, because it is back and forth. The total trip, is back and forth, so it is actually 10 light years times 2. So the total way is 20 light years, and the speed is 80% of the speed of light, that is to say 240,000 kilometers per second. So total way, that is 20 light years divided by the speed, is the total time, that is 25 years. So the total trip, the total journey is 25 years. So on Earth, the time that is passed is 25 years from the moment that the twin brother left the Earth and went to the star Epsilon and then came back to Earth, the total time that is over is 25 years. The total time that is over on Earth. Yes, and according to Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught times root of 1 minus v squared divided by c squared. So the time T naught is the total time that passed on Earth. We multiply it by root of 1 minus v squared divided by c squared, and actually because of the fact that the twin brother that is in the spaceship travels at a very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation or time lengthening. So the total time will be only 15 years, 10 years less than the time that is over on Earth. And that is because of time dilation. The flow of time on the spaceship is slower than the flow of time on Earth. So there will be a difference of 10 years between the time that flowed on the spaceship to the time that flowed on Earth. The time that flowed on the spaceship is 15 years, and the total time that flowed on Earth during the journey is 25 years. Okay? This is, of course, according to special relativity, that time dilation is occurring whenever someone travels at very high speed. From the point of view of the someone that is on rest on the Earth, and he sees someone else that travels at very high speed on spaceship, from the point of view of him, as there is a time dilation. The time on the spaceship will flow slower than the time on Earth. That is the reason that there is 10 years difference between the times that flows on the spaceship and the time that flows on Earth. Okay? But according to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star Epsilon in Eridanus are moving across it at a speed of 80% of the speed of light. As a result, the distance between them shrinks according to the Lorentz transformation. So the distance it must travel is L spacecraft equals to L naught times root of 1 v squared divided by c squared. So L naught is the distance between Earth and the star epsilon from the point of view of the twin brother that stays on Earth. He is not moving, so when he measured the distance between Earth and the star epsilon, it would be 10 light years. But because of the fact that his twin brother moving at very high speed, so the distance between the brother that is moving at very high speed and the star epsilon will be shrinked into 6 light years. And this phenomenon is called the contract of the distance. Contraction of a distance. Because when someone or something travels at a very high speed towards you, there will be a contraction of distance between you and the object that travels at very high speed, according to special relativity. So, from the point of view of the brother that is in the spacecraft, he is not moving, and actually the star epsilon is moving towards him at very high speed, and in this situation there will be a contraction of distance. So the distance between him and the star Eridanus will be no more 10 light years, but it will be shrinked. The distance will be shrinked to 6 light years only. This is according to special relativity. Because when someone is moving towards you at very high speed, there will be a contraction of distance. So the distance contracted from 10 light years to 6 light years only. And the total distance that the brother that is on the spacecraft will have to do actually will be T spacecraft equals to 2 times L spacecraft divided by V. So it is actually the contracted distance that is 6 light years times 2, because it does the distance back and forth. So it is 6 light years in one direction and 6 light years in the other direction when it comes back from the star to Earth. So in total it does 12 light years at the speed of 80% of the speed of light. So the total distance is total way of 12 light years divided by speed of 80% of the speed of light, that is 240,000 kilometers per second. Total way divided by speed is total time is 15 years. So it will take him to do all the journey only 15 years because of contraction of distance. So because of from the point of view of the brother that is on the spacecraft, he is not moving, and the star Eridanus moving towards him at very high speed. And in this situation, there will be a contraction of distance. The distance between him and the star epsilon will be only 6 light years, so the total distance that he must to pass is 12 years. He does it in the speed of 80% of the speed of light, so total way divided by total distance, 12 divided by 80% of the speed of light is 15 years. The journey will take him only 15 years. Therefore, the two twins effectively agreed that the twin in the spaceship will be younger when they meet again, in terms of the twin that remains on Earth due to the effect of time lengthening or time dilation. Yes, because from the point of view of the brother that stayed on Earth, his twin brother is traveling at very high speed, and in this situation there will be a time dilation. The flow of time in the spaceship will be slower than the flow of time on Earth, so the total time will be 15 years. And in terms of his traveling twin, due to contraction of distance, as I have already explained, from the point of view of the brother that is on the spaceship, he is not moving, and the star epsilon is moving towards him at very high speed, and in this situation, according to special relativity, there will be a contraction of distance. The distance between him and the star epsilon will be only 6 light years, and the total distance that he must to pass is back and forth 12 light years, and he does it in 80% of the speed of 80% of the speed of light. So the total time that it will take him is total way divided by speed, 12 light years divided by 0.8 is 15 years. Okay? Thank you very much.